Hey everyone, my name is Andile and welcome to Analytical Geometry. Please don't skip this intro as it is very important. This video covers everything that you need to know to get a minimum of 60% and above in this section of the paper. It is very important that you watch the video in order. Why? Because as we move along, we're going to come across some concepts that I've already explained earlier in the section. So I won't be going deep into them again. They've already been broken down properly before. So there is no need to repeat as already I've explained it in a deeper sense. Now, if you're currently sitting below 50%, I highly recommend that you start with Solve for X, not because I want to discourage you, but because this section is foundational. And if you understand Solve for X, trust me, everything is going to be easier. And again, in this video, if we come across anything that is related to Solve for X, I'm not going to go deep into it as I'm going to assume the fact that you already know the knowledge. Hope that makes sense why it's very important to basically start with Solve for X. And again, Solve for X is a foundation of every topic because you're going to come across it in every topic that we're going to do from now on, right? The video breakdown. The video is divided into two sections. Section 1, straight line geometry. Then section 2, circle geometry. This video is pretty long, so to help you out, I've added timestamps in the description. You can use them to jump to specific parts if needed. Again, right? Just very important. Only use it to jump into sections if you already know the fact that the previous sections you already understand. If you don't understand, make sure the fact that you go in order. As I said, the fact that everything is a build up. Hope that makes sense, right? So with that said, we can start with the video.
So now what we're going to do is we're going to do analytic geometry, and we're going to start with grade 10 and grade 11. It's a little bit of revision because of half of your questions is from grade 11 and the other one is grade 12, right? So first you need to know simple components like your distance formula, your gradient and all that. And we're going to go through it bit by bit, right? So the first thing that we're going to discuss is the distance formula. So the distance between 2 points, which is in our case, the 2 points here from the formula is AB, right? It's going to be what? The square is going to be x2 minus x1 all squared, right? Plus y2 minus y1, right? What's important to understand here is that if you're going to start with x2, right, then the following one, you need to start with y2. And if you decide to start with x1, just know the fact that the following one needs to match up with that one and start with what you call this y1, right? So consistency is very important here, right? So now let's just do an example on distance formula, right? So with distance formula, we have the following. So let me just take up my pen. Is that you're given a point P, which is -5 and 4, and Q, which is 0 and 6, right? It says determine the distance between PQ. They could also say the fact that determine the length between PQ. Distance and length, it's exactly the same thing. So now let's do that, right? So with how I do my distance formula is that I would name it. So in the formula, instead of saying x2 and x1, I'll just say xp and xq, right? And yp and yq, right? That way I know the fact that which coordinate I'm taking, right? I find it easy to do it that way. So it's going to be what? It's going to be PQ is equals to the distance, right? So it's going to be what? It's going to be X, right? It's going to be XP minus XQ, right? All squared. And this is going to be minus, plus, sorry. Then this is going to be YP minus YQ. Do you see the fact that since I started with XP, my Y needs to follow as Y, right? YP. And this is going to be all squared, right? So this is going to be all squared. So let's substitute. So it's going to be PQ is equals to the following. It's going to be the square root. Then here, what's XP is -5, right? What's XQ is -0. Then this is going to be all squared. Plus, this is going to be -4, right? Then this is going to be -6. right? And this is going to be all squared. So when you pass that into the calculator, you're going to get the square root of -5, right? Minus 0, all squared, plus that's going to be -4, right? Minus 6, then it's going to be all squared. So you're going to get your answer as root 15. So there's going to be root 15. So this is going to be your answer for finding the distance. So now what we're going to talk about, the midpoint of a line segment, right? So if you have a line, which is you have a line AB, right? Then the midpoint, what is the midpoint? Is from the distance here. So it's the distance between here till the midpoint, and this distance from the midpoint to the other point. These two are equals to each other, right? Midpoint cuts the line equally, right? So this whole line, which is, I'm going to highlight it, right, is cut equally here at this point, right? So now, how to find the coordinate of that point, this is the formula, right? So that's how you would find the midpoint of what? Of a line segment, right? So to find the midpoint of the line segment AB, which is it's at A, you're going to use this formula to do that, right? So now with that said, let's do an example on how to find the midpoint, right? So it says, given that point P and point Q, determine the midpoint is. So in our case, this point here, right, is actually S, right? And this point here, it's what? Is P, right? And this point here is Q, right? We are determining the coordinate S because we are given that P, right? We already given P and we already given Q, right? So we want this one. So we're going to use the midpoint formula, right? So as I said when we were doing distance, is that I love, instead of using x1 and x2, I love using alphabets, right? So with the midpoint here, which is our midpoint, is going to be S. So our midpoint, right, is going to be S, which is the coordinate is going to be x is to y, right? It's going to be equals to what? Do you see the fact that it's adding x1 and x2? Meaning it's the same as adding xp plus xq and dividing it by 2, right? Then for the y coordinate is taking yp plus yq and dividing it by 2. So that's how you would find the midpoint between this line segment, right? The line segment PQ. So when we do that, it's going to be what? It's going to be -5, right? Plus 0 divided by 2. Then is to what? Is to -4 plus 6 divided by 2, right? So that's going to give me what? That's going to give me -5, right? Plus 0 divided by 2, right? Which is going to give me -5 over 2, right? So then for y, it's going to be what? It's going to be -4 plus 6 divided by 2, which is going to give me 1, right? So here, this point here, this x here, do you see the fact that this x here is basically x of s is basically equals to -5 over 2, then y of s is equals to 1. So meaning s, the coordinate, right, is basically equals to -5 is to 1. So that's how you would find the midpoint of this line, right? So now let's do a situation where now they gave you what? They gave you they gave you a point and the midpoint, and they didn't give you the other coordinate. Then you wanna, you need to solve the other coordinate, right? So let's read the information. It says, given that point A, right, which is going to be 3:3 and the midpoint. So you're given the midpoint on the line AB, right, is -1/2 is 2, -2. Determine the coordinate B. So what are you given? So let's say you're given this A. So this is nice because we wrote it in A. So let me just write it. You're given A, which is 3, is 2, 3, right? And you're also given the midpoint, and the midpoint, I'm going to say it's -1/2 is 2, -2, right? And you are not given this point B, right? So they want you to determine this point B. So do you see the fact that you have this, you need this. So you can still use the midpoint, right? The midpoint formula to find point B, right? So what do you know? You know the fact that the midpoint, right? So I'm going to just write it in coordinate. I'm going to say M. We know the fact that M, which is the midpoint, because they didn't tell us what is the midpoint, like in terms of alphabet, they just told us the coordinate. We know that the midpoint, and I'm just going to rewrite the formula XY is equals to what? Is equals to, I'm going to write this in terms of A and B, right? So this is going to be what? Because the line, remember this midpoint is on the line A and B, right? So it's going to be the same as XA plus XB, right? Divided by 2, right? Right? Then here's going to be what? It's going to be YA, right? Plus YB divided by 2, right? So now, what is the given information? I'm going to substitute the midpoint. We know that the midpoint they gave us is what? As negative 1 over 2 is to negative 2, because they gave us, right? Then they gave us the point A, right? So let's substitute. It's going to be 3 plus, we're looking for the coordinate of B, so XB, we're not given. That's what we're calculating. Then it's going to be 2. Then this is here is going to be 3 again. Plus, then this is going to be YB. And this is going to be divided by 2, right? So now we have this like this, right? So what we're going to do is we're going to equate the X coordinate to the X coordinate. So meaning this one is going to be equals to this one, right? Then we're going to equate the Y coordinate to the Y coordinate. So this is going to be this one and this one, right? So let's do that, right? So it's going to be for the X, it's going to be what? It's going to be negative 1 over 2 is equals to 3 plus XB, right? Divided by 2. Do you see the fact that B is the only unknown here? So let's cross multiply and solve for XB. So we're going to have negative 1 multiplied by 2, right? Then here's going to be 2 open bracket. It's going to be 3 plus XB, right? So here we're going to have negative 1 multiplied by 2, which is going to be negative 2, is equals to distribute the 2 is going to be 2 multiplied by 3, which is going to give us 6, right? That's going to be 2 multiplied by XB, which is going to be plus 2XB, right? Take the 6 to the other side. It's going to be negative 2 minus 6, which is going to give us negative 4, right? It's going to be negative 2, no. Negative 2 minus 6, which is going to give us negative 8. It's equals to what? To 2XB, right? Divide both sides by 2. So it's going to be equals to what? It's going to be that XB is equals to what? It's equals to negative 4, right? So now I'm going to equate the green ones, which is the Y coordinate. So it's going to be negative 2 is equals to 3 plus YB divided by Y divided by 2. Cross multiply, going to be negative 2 multiplied by 2, right, is equals to, yes, divided by 1. So it's going to be 1. That's going to be 3 plus YB, right? So here we're going to have negative 4 is equals to what? It's equals to 3 plus YB, right? Take the 3 to the other side. So it's going to be negative 4 minus what? Minus 3, which is going to give us negative 7. So this is going to be negative 7 is equals to YB. So therefore, we know that YB is equals to negative 7, right? So we know that the coordinate of B is made out of X. B is to YB. So meaning the coordinate here is B is to what? Is to negative 4, is to negative 7. So that's how you would solve this question. So now we're going to move to what? To gradient, right? With gradient, it says a gradient M describes the slope or the steepness of a line joining 2 points, right? The gradient of a line is determined by the ratio of the vertical change, right, to the horizontal change, right? So this is what they mean. The vertical change is to the, what you call this, to the horizontal, right? It's y2 minus y1 divided by x2 minus x1. Or it could be y1 minus y2 divided by x1 minus x2, right? So here, what is important if you look at the formulas here is that it needs to be consistent. If in the numerator you're going to start with y2, just make sure the factor in the denominator, you're going to start with x2, right? Even here, if you're going to start with y1, just make sure the factor in the denominator, you're going to follow up with what you call this, x1, right? You can't start with y2, right? Then in the denominator, you're going to say x2. This is completely wrong. This will be regarded as wrong. See, remember that you need to be consistent. This will be completely wrong. So same applies with your distance formula. Consistency is important, right? Even with your with midpoint, really, consistency is not important. But with your gradient and your distance, consistency is very crucial there, right? So this is the gradient formula. So now let's do an example, right? It says the following. Let me take my pen. It says, given that the point P, which is -5, is to -4, and Q, right, which is 0 is to 6, determine the gradient of PQ. So the gradient of PQ, right, is the same as I said, the fact that I love using the actual coordinates of the 2 points. So we know the fact that it's P minus YQ, right, because we have P and Q, divided by what? By X, because I started with YP, so it's going to be XP minus XQ, right? So that's going to be equals to what? So that's going to be equals to, let's substitute, so it's going to be -4, right, minus 6, so it's -4, right, minus 6. Then here is going to be what? It's going to be -5, right, minus 0. So by starting to the calculator, you're going to have -4 minus 6, then it's going to be -5 minus 0, which you're going to get as being 2, right? So your gradient of PQ is actually 2. So that's how you would solve this question. So now we're going to move to the equation of a line, right? So with the equation of a line, we have this 3 situation. You have 2 points where, what you call this, you have the 2 points form of a straight line equation. So you can use this one, right? You have a gradient point straight line situation, which is you can use this one, or you have the x-intercept, which is this one, right? Either one of them, either one of the equation, you can use any one of them, right? It's not compulsory to use a specific one, right? Just know one, know how to use it, then just use that, right? So now we're going to do an example, right? So it says what? It says find the equation of a straight line, right, passing through the point P and Q, right? So I'm going to use the what? I'm going to use this one for this question that I'm doing, right? So I'm going to use the one that says y is equals to mx plus c, right? So the nice thing is that we already know what is the gradient of PQ. So we already know that the gradient of PQ is equals to 2, right? So now substituting my m, so it's going to be y is equals to, my m is 2, that is going to be what? It's going to be x plus c, right? So now from here, we're going to substitute, right? We're going to substitute either P or Q. It really doesn't matter between the two here into the formula, right? So substitute, I'm going to substitute P into Y, right? To solve for C, to solve for C, right? To solve for C. So let's do that. So it's going to be what? It's going to be -5 is equals to 2, then this is going to be -1, then it's going to be plus C, right? So this is going to be -5 is equals to -2 plus C. So you're going to have -5 plus 2 is equals to -3. So your C is going to be equals to -3. So therefore, your equation is going to be y is equals to 2x minus 3. So that's how you would find the equation of the line PQ. So now I want to talk about what is collinear, right? Collinear means the fact that if you have a line, so this is a line, right? So this is a line. And within that line, we have maybe like a couple of points. I'll just say 3 points. And the point is point A, and this is point B, and this is point C, right? With collinear, what does it say? It says the fact that the gradient of this portion of this line, right, is going to be equals to the gradient of this line, which is going to be also equals to the gradient of this line, right? So that's what collinear says. It says If we have a line, a straight line, right, and we have points of them, the lines, the segments of the lines, right, the small portions of the lines, all their gradient throughout are equal. So just to translate this, it's going to be basically saying that the gradient of AB is going to be equals to the gradient of what? Of BC, which is going to be equals to the gradient of what? Of AC. So what does it mean? How can we use it? Is that, let's say you're doing a question and you calculate the gradient of AB. If we have the gradient of AB, we automatically have the gradient of BC, and we automatically have the gradient of what? Of AC. So you don't need to recalculate this too if you've calculated one of the line segment within that long straight line. I hope that makes sense. So that's just collinear in general. Now, what I want to talk about the inclination line, right, with positive gradient. So what does it mean when it has positive gradient? Is that first, your gradient needs to be between 0 and 180, right? Anything that's greater than this is considered what? A negative gradient. And you're going to see when we do an example that's regarding that, right? So this is how your angle of inclination needs to look. Do you see this? It needs to be an acute angle. So this needs to be an acute angle, right? So positive gradient, we're dealing with an acute angle. Just remember that, right? So now let's just do an example that's dealing with what? That's dealing with an acute angle, right? So here we are given that the gradient is equals to 1/2, right? And we need to determine the angle of inclination. So what is the relationship between the angle of inclination and gradient? Is this one. Is that the gradient is equals to 10 of the angle of inclination, right? So here, what are we given? We're given the gradient and we need to determine this angle, right? So we have that 10 theta, right, is equals to what? It's equals to gradient, right? We have the gradient, we need the angle. So it's going to be 10 theta is equals to what? So theta is equals to 1/2. So theta is going to be equals to 10, right, of 1/2, right? So when you say that, so if you say 10 of 0,5, right, it's going to give you what? You're going to see the fact that your angle of inclination, right, is going to be 26,57, right? Do you see the fact that this angle is definitely between this, right? Do you see the fact that 26,57 is definitely between 0 and 180? So that's going to be how you find your what? Your angle of inclination when we're given the gradient. So now let's say they gave you the angle of inclination and now they want the gradient, right? Still we use the same relationship, right? And with this one, we need, since our angle is what is less than what is an acute angle, right? Is that we need to make sure that our gradient needs to be positive, right? So here it's going to be what? It's going to be that m is equals to what? To 10 theta, right? We are given theta, so it's going to be m, and we're looking for gradient, which is m. So it's going to be 10 of 70 degrees, right? So therefore, m is going to be equals to 10, 70, which is going to be equals to what? 2,75. So your gradient here is going to be 2,75. Do you see the fact that our gradient is positive? So that's how you're going to do it if you're given now the angle of inclination and you need to find the gradient. So now we're going to move to inclination of a straight line of a negative gradient, right? Still use the same formula of m is equals to 10 theta, right? But it's going to differ here, right? It's going to differ because of now we're dealing with negative, right? Now, the minute you see the fact that your angle is what? It's greater than 90. So theta is greater than 90 degrees, right? So anything that's greater than 90 degrees, then your angle is going to be a negative. Do you see this? It's going to be an obtuse. Do you see that? Not only going to be what? Do you see how the angle is? It's going to be an obtuse angle, right? The minute it looks like this, just know the fact that you need to get what? A negative gradient, meaning this m needs to be negative, right? So now let's just do the first one where we are given what? We are given the gradient and we need to determine the angle of inclination, right? So now it says what? It says given that m is equals to -1/2, determine the angle of inclination, right? So here we're going to use the formula. So you're going to say m is equals to 10 theta, right? So m is what? Is equals to negative 1 over 2. So it's going to be the same as 10. Theta is equals to negative 1 over 2, right? So you're going to find at 10. So it's going to be at 10, right? Here we do substitute the negative. So it's going to be negative 1 over 2, right? So when you punch that into the calculator, you're going to say at 10, right, of negative. Then you're going to say 1 over 2. Punch that into your calculator. You need to have that negative. You're going to get that your answer is going to be now negative 26.57, right? We do not want our angle to be what? To be negative, right? So you're going to say this plus 180, right? So always remember, when you get a negative, you add by 180 because of you want a positive number, right? So it's going to be a positive degree. So it's going to be negative 26, right, 57 plus 180, right? So your answer here is going to be 153.43 degrees. Remember, negative angle, right? Negative degrees or negative angle of inclination, you always add by 180, right? Negative add by 180 to get a positive, right? So that's how you would do this question. So now you are given that the angle of inclination theta, right, is equals to 145, determine the gradient. Here, since this is greater than 90, remember the fact that our gradient needs to be what? Needs to be negative, right? So here we know that the relationship is m is equals to 10 theta, right? They gave you theta. So it's going to be m is equals to 10 of 145 degrees, right? So therefore m is going to be equals to, when you say 10 of 145 degrees, you're going to get that your angle is going to be what? Your gradient, sorry, is going to be 0 and negative 0.7. So do you see the fact that your gradient is negative? So which matches up with the fact that theta needs to be anything that's greater than what? Greater than 90 degrees, right? So that's how you would do if you have angle of inclination that's greater than 90 degrees and you need to determine the gradient. So now moving to past paper questions, right? So we have the fact that question 3, it says in the diagram, PQ R is a vertex of a quadrilateral, right? So there are points on the quadrilateral, and they say that point R on the x-axis. So we see the fact that point R is basically on the x-axis, meaning the coordinate is going to be some x value and 0, right? And it tells us the fact that QR is produced, or QR is produced in, meaning QR extends to n, right? Such that they tell us this important information. Let's highlight it, right? That QR is equals to 2 of Rn. And they tell us that Sn is drawn, right? So Sn is drawn. Then they tell us the fact that PTO is equals to 71.57 degrees. And they tell us the fact that SRN is equals to what? It's equals to theta, right? So now the first question, which is going to be 7.1, right? So 7.1, it says what? It says we need to determine what? We need to determine the following. We need to determine the equation of SR. So is SR is going to be this one, right? What do we see? We see the fact that the line has what? Has a 90 degrees, right? So if it has a 90 degrees, meaning the line, it's a vertical line, it's going straight. What do you know about vertical lines is that the equations are equals to the x coordinate, right? So again, is that point S and point R is going to share the what? The same x coordinate. So this is going to be 3 and 0 here. So here, the equation of SR is basically going to be x is equals to 3. So this is going to be x is equals to 3, right? Then 7.2, it says we need to determine the, what you call this, the gradient of QP, right? So where's QP? Q is here and P is there, right? We need to determine what the gradient. What do we see? We see the fact that they gave us what? They gave us the angle of inclination, right? So we're going to use this relationship, which is 10 theta is equals to the gradient. So meaning the gradient is equals to what? Is equals to 10. Then this is going to be what? This is going to be 71,57. They say to the nearest integer. So it's going to be gradient is going to be equals to what? Is going to be 3. So our gradient here is going to be 3, right? Then 7.3, right? It says what? It says the equation of QP in a form of y is equals to R mx plus c, right? So we already know the gradient of what? Of QP. So we know the fact that this is going to be y is equals to mx plus c. So substitute your m. Remember we calculated it as being 3. So this is going to be 3x plus c, right? So now, since we have this point, we can substitute this point to solve for what? To solve for c. So let's do that. So it's going to be negative 2 is equals to what? To 3, open bracket, negative 7, right? Plus c. So it's going to be negative 2 is equals to 21. Negative 21 plus c. Take the 21 to the other side. So therefore, c is going to be equals to positive 19, right? So y here is going to be equals to 3x plus 19, right? So we are sorted with that one, right? So now with 3.4, not 3.4, why do I keep on saying 7? So let's say 3.4, right? So with 3.4, it says the length of QR, so it's QR, so QR is here. So let's just change up the color. QR is going to be this one, right? We need to find the length of that. Do you see the fact that we have both the Q and the R coordinate, right? So we need to find the length. So it's using what? The distance formula. So it's the same as what? It's the same as saying Q R, right, is equals to the distance formula. So you're going to have what? It's going to be XQ minus XR all squared plus it's going to be YQ minus YR, that's going to be all squared, right? Substitute that, you're going to have the following. It's going to be XQ is negative 7, so it's going to be negative 7. Then it's going to be positive 3, so it's going to be minus 3 all squared. Then here's going to be negative 2. Then it's going to be minus 0. Then it's going to be all squared, right? Punch that into the calculator, you're going to get the fact that your distance here is going to be root 104, which is the same as 2 root 26, right? So that's the distance of QR, right? So we're done with this. Never mind the 7s, right? I meant to say 3. So now we move on to 3.5, right? So they tell us the following, and let's just, with 3.5, I want to do it here in a separate diagram because if I want to discuss something, right? So first, let's go to the equation because that side I can't see the equation. It says we need to determine that 10 of 90 minus what? 90 minus theta, right? So we need to determine where 90 minus theta is, right? So we remember the fact that we're looking for 10 of 90 minus theta. Right? We're given theta here, right? So since this one is a straight line, do you see the fact that since this one is an actual straight line, right? Meaning it goes straight and it's perpendicular. Do you see? It's perpendicular, so it's like straight line. It's a line that's like vertically straight, right? Is that using n as the vertex, I can find the height, right? So I'm going to find the height here. So I know when I find the height cuts on the straight line, which is going to be 90 here, creating a 90 degrees. And the reason why I can create a 90 degrees is because if this is an actual straight line, it's not on the side. So I can't create, so with that said, I can't create a vertex on this line. Do you see the fact that if I took this triangle, just to emphasize what I'm saying, if I took this triangle here, right? This triangle, and I'm going to take it like this. If I take this triangle, do you see the fact that the line QR is not a straight line? So I can't find the height from this point. Do you see that? Because of it's not going to land on a straight line, right? but I can find the height on this line, on this green one, and going from Q, because of it's going to create a 90 degrees. Your height needs to be 90 degrees, right? So that is the same concept that I used there, right? Is that from in, I can go down and it's going to create a 90 degrees. Meaning here, this is going to be theta. So with that said, let me just erase the following. I was just showing you on how to find the height, right? The height needs to land and it needs to create a 90 degrees. Remember that, Dane? Your height always needs to land down and create a 90 degrees. So with that said, right, we know the fact that if this is 90, meaning this portion here, do you see this portion here? Right, is also going to be 90, right? Then, if this is 90 and this is theta, what's this angle? It's going to be what? Using sum of angles in the triangle. So it's going to be 90 degrees plus theta plus this angle, which is, I'm going to call it x, right? It's going to be equals to what? Is equals to 180 degrees, sum of angles in a triangle. So now we want to make x the subject. So it's going to be x is equals to 180 minus 90 minus x, right? So it's going to be x is going to be equals to what? It's going to be equals to 90 minus x, right? 90 minus theta, that's what I mean. So this is going to be the same as 90 minus theta. Do you see where that 90 minus theta comes from? It comes from here, right? Since it comes from there, right? What do we see? We see the fact that that angle, remember the fact that this is the same as the angle of inclination, right? This is the same as the angle of inclination. And what do we know about the angle of inclination? It's related to some gradient, right? The gradient of that line. So here, this angle here is related to which one? It's related to this line. Do you see the fact that this angle is on this line? So do you see the fact that this is on the line of QR, or you can say the fact that QN. So we know the fact that since we have QR, right, because of we know the fact that this is what? This is 3:0. So I'm just going to relate it with that because of it's going to be the same line. The gradient from QR and QN is the same thing. So this is basically equals to the gradient of that line, which is going to be QR. Right? So knowing that relationship, I can basically find the gradient, right? I can basically find the gradient here, right? So that's what I'm going to do. So I know the following. It's going to be that 10, because they want 10, 90, right? Minus theta is going to be equals to the gradient of QR. But we know the fact that using the gradient formula, so first let's reduce this. Remember the fact that this is going to be what? It's going to be like this. So this is 90 minus theta, right? So it's going to be in the first quadrant. Since it's 10 and 10 does not have a cofunction, this is going to be what? This is going to be the same as 10 theta, right? It's going to be equals to what? 2 MQR, right? So now let's find this. So it's going to be 10 theta is equals to what? Is equals to, this is going to be the same as YQ minus YR divided by XQ minus XR. Just substituting the gradient formula. Meaning 10 theta is going to be equals to what? What's YQ? What you call this? What's going to be? What you call this? What's YQ? YQ is -2, right? Then R is going to be what? It's going to be -0, right? Then it's going to be -7, right? Then it's going to be -3, right? So it's going to be what? It's going to be -2 minus 0. Punch that into the calculator. -7 minus 3, which is going to give me what? Which is going to give me that 10 theta is basically equals to 1/5, right? So let's go back and check what they want. They just want 10 theta, right? We're not solving for theta here. So we need to just give it its value, which is exactly this value, is that we're going to have what? We're going to have that 10 theta is equals to 1/5, right? So now with that said, we can move, we know the fact that here 10 we did the calculation on the next page. 10 theta is equals to 1/5, right? So now moving on to what? And that I'm going to need a separate page again, right? So now moving on to the area of what? We need the area of triangle RSN. So let's go to triangle RSN. So we know the fact that this is triangle RSN, right? So this is the triangle that we're going to look the area for, right? So I'm going to take it out. I'm going to take the triangle out. So when I take it out, it's going to be like this. Why is my line not straight? So just erase this. I'm taking it out. So this is going to be the same as what? This is going to be the same as like this. Right? And it goes like this. Then it goes like this. Then this is basically S, right? R, and this is N, right? So now remember when we did this equation, we determined the fact that from here, because this is a straight line, I can determine a height, right? So I can determine the height, which is my height is going to be here, right? Which is going to create a 90. And this is theta, remember? And this is what? This is 90 minus theta, right? So that's all the information, right? And we know the fact that this is SRN, right? So remember what area? It's area, right? Area of a triangle. So triangle R is N is equals to what? To half base, right? Times height, right? So here, what is our base? Our base is where the height cuts, right? So our height cuts here, right? So meaning S R is the base, right? Which we can find because the distance between here and here is just going to be this y coordinate. So this distance here, it's actually 6. So there we have our base, which is 6, right? So it's half base, right? So we have the base. Now we need height, right? So the height is this one, the one with the dotted line, right? We need to determine that. But what do we know? We know the fact that if I take out that triangle, right? I'm just going to still continue writing it in the dotted line, which is going to be 90. No, now we know the fact that this is theta. Remember the fact that this is what? This is 90 degrees minus theta, right? What do we know? We know the relationship, since this is a what? It's a right angle triangle. We know the fact that 10 of 90 minus theta is equals to what? Is equals to 1/5. Remember when we did the calculations here, right? This is even if you stop reducing it. Let's say you didn't reduce it. This is basically the same as if you said 10, if you did not reduce it, right? 10 of 90 minus theta is basically equals to 1/5, right? So that's what it is, right? So 90 minus theta is equals to 1/5, right? So knowing that relationship, what do we know? We know the fact that 10 of 90 minus theta is basically what? It's opposite over adjacent, right? So meaning 1 is opposite, then 5 is adjacent. So from here, we know the fact that opposite is going to be this one. So this one is going to be 1, right? Then adjacent is going to be this one going down from this angle. Remember the fact that it's from this angle because that's 90 minus theta. So that's going to be 5 here, right? So now fill in everything. Opposite is going to be 1, is going to be here. Then adjacent is going to be where? It's going to be this one, right? Which is going to be what? Which is going to be your h. Do you see the fact that your h, your height is 5? So from there, we know the fact that h, right, your height is equals to 5. And it's from this relationship, right? So now we can find the area. So the area, right, of triangle RSN is equals to a half, right? Base is what? Base is 6. Then your height is 5, right? So it's going to be what? So it's half, right? Remember, it's half base times height, right? So it's going to be 1/6 1 over 2, sorry, then it's going to be 6, right? Then it's going to be 5. So the area there is going to be equals to 50. So that's how you would find the area of this question. So it's 15, remember, 15. What is this in what? In unit square. So that's going to be unit square. So that's how you will find it. So now we're going to do grade 12 analytic geometry, right? So the thing that you need to know is the equation of the circle. So the first thing that we're going to talk about is the equation of a circle at what you call this with the center at the origin. So what does it mean? It means the fact that the center of the circle, which is this one, right, is at the origin where I'm putting across, right? So meaning here the coordinate is 0, 2, 0, right? So the properties now, what do we see? We see the fact that the equation of a circle, right? So the equation of a circle when the center is the origin, meaning the center is OO, this is the equation of the circle is x squared plus y squared is equals to r squared, right? So that's the equation of the circle. So now let's do the first example, right? Talking about the equation of a circle with the center at, what you call this, with the center at the origin, right? So let me just change my pen color. The first example says, given that the center with the center O, right, which is at 0, 0, and a radius 3, which is 3 units, right? The first question says what? Determine the equation of the circle. So we know the fact that when the center is at the origin, right, or the center is O, it's 0, 0, then this is the equation that we're going to use. So for number 1 here, right, it's going to be what? We're going to say x squared plus y squared is equals to r squared, right? So the only thing that we need to substitute is our r. So let's do that. We already know the fact that the radius, which is r, is equals to 3. So let's substitute that. So it's going to be x squared plus y squared is equals to what? Is equals to 3 all squared. So this is the same as x squared plus y squared is equals to what? Is equals to 9. So that's how you would find the equation of the what? Of the circle. Of the circle, right? So number 2, it says show that the point T, right, which is negative root 5 and root 5, right, lies on the circle. So what does that mean, right? When we want to check whether a point lies on the circle, is that from the equation of the circle, which we know the fact that this is x squared plus y squared, right, is equals to 9, right? Is that when we substitute this point, which we're going to substitute on the left-hand side, right, it needs to be exactly equals to 9. If when we substitute is not equals to 9, then they are not, what you call this, the point T is not, what you call this, does not lie on the circle. So let's do that. So taking the left-hand side, right, so taking the left-hand side, which we have as what? As x squared, right, plus y squared. So let's substitute. It's going to be negative square root of 4, right, all squared, plus it's going to be root 5. That's going to be all squared, right? So that's going to be the same as what? That's going to be the same as 4, right? And here's going to be the same as 5. What's 4 plus 5 is going to give us 9. Do you see the fact that it's 9? So this is going to be the right-hand side. So this is equals to the right-hand side, right? So since the left-hand side, right, is equals to the right-hand side, therefore T, right, lies on the graph, So that's how you would answer this question. So now we're going to do example 2, right? It says what? A circle with the center O, right, which is at point 0, 0, passes through the points P, right, which is negative 5 and 5, and point Q, which is what? Which is 5 and negative 5, right? So the first question says what? It says determine the equation of the circle, right? So if I had to just draw a rough sketch, if this is the circle, right, we know the fact that O is the origin, so it's going to be here. This is going to be where the center is, and it's going to be like this, right? So when they say the circle passes through the points P, so meaning P will be here, right? So P is what? Is -5, so it's on the negative. There's positive. It's positive what? It's positive y, right? So P is going to be here. So P will be here, right? Then Q, right? Do you see the fact that Q is the same coordinate? It's like it's reflecting on the other side, right? So Q would be here, right? So Q would be here. So which is going to be 5, right? And -5, right? So now to find the equation, remember the fact that the formula of the equation is what? Is x squared plus y squared, right, is equals to r squared. So we need your r. Do you see the fact that what do we need? We need r. So you can either use the point P, and we know the fact that this point here at center is 0, 0. You can use either point P, right, and the center to find your r, or you can use point O and point Q and your center to find r. So let's do that. So now we're finding r, right? So r is going to be this distance. Let's just highlight it, right? So r is going to be this distance here, right? So it's the distance between what? Between O and what? O and Q, right? So it's the distance r is equals to what? To the distance between O and Q, right? So that's going to be the same as what? Distance formula. Then we're going to have what? X O minus X Q all squared plus you're going to say Y O minus Y Q all squared, right? Let's substitute. It's going to be the following, right? It's going to be what's XO? XO is O, so it's going to be O minus what? Minus X, XQ, which is 5. And that's going to be all squared. And the other one is 0 minus 5 all squared. Punch that into the calculator, right? You're going to get, it's going to be 0 minus 5 all squared, right? Plus, then it's going to be 0 minus, then minus 5, right? All squared, which is going to give you 5 root 2, right? So this is what this is r, right? So now let's substitute r into our second equation. So it's going to be x squared, right? Plus y squared is equals to what? Is equals to 5 root 2 all squared. So it's going to be x squared plus y squared is equals to, so you're going to say 5 root 2, and when you square that entire thing, you're going to get the fact that it's going to be equals to 50. So that's going to be the equation of the circle, right? Then the second question says what? It says calculate the length of PQ, right? So the length of PQ is going to be from here to here. We already know that P is what? It's -5 and 5, right? So it's going to be number 2. The length of PQ is basically equals to the square root, right? Then it's going to be x of P minus x of Q, right? And all squared minus, then this is going to be plus, y of P minus y of Q, right? And this is going to be all squared, right? So this is going to be the same as having the following. So this is going to be the square root, right? What's x of P is -5. Then x of Q is -5, all squared. Then here is what is our y of P, which is 5, minus then y of Q, which is -5. So what are you going to get there? You're going to get the following. You're going to get that your PQ is equals to what? Is equals to 10 root 2, right? So that's going to be your answer for number 2, right? Then number 3, it says explain why PQ is the diameter of the circle, right? So PQ is a diameter because of if I take, if I take the distance, right? So to check that, right, we know the fact that the relationship between the distance, the diameter, the relationship. So we need to know the relationship. Basically, let me just write it down. The relationship between the diameter and radius. So what do we know about the relationship is that, so the relationship is what? Is that the diameter, which is, I'm going to name it D, is equals to what? Is equals to 2 times of the radius. That's the relationship, right? So if I multiply my radiuses twice, so I'm checking whether the left-hand side basically is equals to the right-hand side, right? So I'm going to take my my right-hand side, right, which is equals to 2 multiplied by r, right? Then we know the factor is going to be 2 multiplied by, remember the fact that we found our r as what? As 5 root 2, right? So that's going to be what? If you say 5 root 2 multiplied by 2, you're going to get the fact that this is going to be 10 root 2. So by that, we see the fact that this matches up with the what? With the left-hand side. So this proves the fact that what? It's actually PQ is actually what? It's actually a diameter of the circle. So now we're going to move to the second part, which is what? Which is equation of a circle with the center at A, B, right? So meaning it's no longer at the center, it's any point on the what? On the Cartesian plane, right? So this is how it looks. Do you see the fact that we have a circle and the center of the circle is no longer here, but it's a point, right? So that point, we're just going to name it as variable, which is going to be what? Which is going to be A, B, right? So here it says what? It gives us the formula of when we're no longer dealing with the center, but we say we're dealing with the center of any variable, right? So here, before we just continue and do the first example, I want to discuss a few things, right? Is that here, remember the fact that this circle is, I can't say it's not a function, but it falls under like functions, right? Because it's on the Cartesian plane, right? So it means the fact that they could ask you a question where they shift the graph to the left and they shift the graphs to the right, right? So this one, right, this A, right, moves the graph up, left or right, right? And it makes sense because of its with X, right? It's going to move the graph left or right. So it's going to act opposite its sign. So if A is greater than 0, meaning it's positive, the graph moves to the what? To the left, right? Then if A is less than 0, meaning the graph moves to the right, moves to the right. And then now we're going to talk about B. And I just need space here. B moves the graph up or down, right? Because it's with Y, right? So it moves the graph up or down, right? So meaning now when B is greater than 0, it's going to work the way A works, right? I know when we were doing other ones like P and Q, the one that's related to Y, it basically maintains its sign. But here in circles, it does not maintain its style. Its sign, right? So when B is what is positive, the graph will move. Instead of moving up, it's going to move down, right? Then when B is less than 0, the graph will move up. So it's moving opposite its sign, right? So that's that's just a couple of notes that you need to take into account when dealing with when now the graph is no longer in the center, right? The center is no longer at like the 0.00, but it's outside. Is that how A shifts? You need to know when it's positive, how does it move? When it's negative, how does it move? And when B, when it's positive, how does it move? And when negative, how does it move? So now we're going to do example 1, right? It says F, which is 6, negative 4 is a point in the circle. So we know the fact that it's a point in the circle. Then they tell us the fact that with the center, 3 is to negative 4, right? So the first question says determine what? Determine the equation of the circle. So we know the fact that the equation of the circle, since the center is not 0, 0, is going to be what? It's going to be the 1 on the side. So it's going to be x minus a all squared, right? Plus y minus b. Then it's going to be all squared is equals to r squared, right? So now we need a, b, and r, right? So in our case, what's a, right? So if we rewrite this equation, since this is what? This is positive. So when we rewrite it here, it's going to be, this represents a and this represents b, and so since this one from the outside, the center they gave us as what? As positive 3. So this is going to be x minus 3 all squared, opposite sign, plus it's going to be y. Since this one is what? It's negative, so it's going to be plus 4 all squared is equals to r squared. So now we have substituted a and b. What do we need to substitute? We need to substitute what? We need to substitute r, right? To find r, you're going to use this point here, substitute it, and that's going to give you your r, right? So it's going to be what? So it's going to be the following. It's going to be what? It's going to be, for x, it's going to be 6 minus 3. Then this is going to be all squared. Plus, this one's going to be negative 4 plus 4. That's going to be all squared. It's going to be equals to r squared, right? Pass that into the calculator. You're going to get your value to be what? You're going to get your value into being, if you say 6 minus 3 all squared, right? Plus, then now you're going to say negative 4 plus 4 all squared. You're going to get your answer to be 9. So 9 is going to be equals to r squared, right? So therefore now substituting everything is going to be x minus 3 all squared plus y, right? Plus 4 all squared. Remember the fact that in the equation you want r squared and we found it as 9. So this is going to be equals to 9. So that's how you will find the equation, right? Then the second one says what? It says, does the point G, right, lie on the graph? How do we test that something lies on the graph? We substitute it on the equation. If the left-hand side is equals to the right-hand side, right, then it lies on the graph, right? So now for number 2, right, we're going to take the left-hand side, right? And we know that the left-hand side is going to be x minus 3 all squared plus y plus 4 all squared is equals to. So this is going to be equals to what? We're going to substitute here. So we're going to substitute. Let me just write it here. Substitute, or let me just do this. So we're going to substitute G to check, right? So we're going to substitute G. So it's going to be what? It's going to be now the left-hand side. It's going to be equals to, it's going to be 3 over 2, right? Minus 3 all squared. Plus, then this is going to be negative 2 plus 4 all squared, right? Pass that into the calculator. You're going to have 3 over 2, right? Minus 3 all squared, right? Then this is going to be plus, then it's going to be negative 2, right? Plus 4 all squared. So you're going to get your answer as being what? As being the following value, as being 6, 2, 5. Do you see the fact that 6,25 is not equals to what? Is not equals to 9, right? Which is not equals to what? It's not equals to the right-hand side. So therefore, we can conclude that what? We can conclude that G does not lie, right, on the circle, So that's how you would do this question, and so now moving to what? Moving to number 3, right? It says, does the circle cut the y-axis, right? Then it says motivate your answer. So to check whether it cuts the y-axis, what do we need to do? So to determine whether the circle cuts the y-axis, we need to find we need to find the y-intercept here. So that's what we're looking for, right? So we're going to find the y-intercept. And we know that y-intercept is let x, right, equals to 0. So remember we have this equation. It's going to be x minus 3 all squared. Plus it's going to be x plus 4 all squared is equals to 9, right? So it's going to be what? It's going to be 0 minus 3 all squared plus, this is going to be y plus 4 all squared is equals to 9. So it's going to be what? 0 minus 3 all squared is going to give us 9. So that's going to be 9 here. Plus what? Plus y. Plus y plus 4, right? All squared is equals to 9. Take the 9 to the other side. You're going to have y plus 4 all squared is equals to 9 minus 9. You're going to have the following. 9 minus 9, you're going to have the fact that 9 minus 9, you're going to have 0, right? So you're going to have 0, square root both sides. So here's going to be x plus 4 is equals to the square root of 0 is 0. So it's going to be 0. Take the 4 to the other side. It's going to be y is equals to negative 4. So your point here is going to be what? It's going to be 0 and negative 4. So the graph, right? So the circle, what I mean. So the circle cuts the y-axis at 0 is to negative 4. So now we're going to do example 2, right? Example 2 says determine the coordinate of the circle determine the coordinate of the center of the circle and the length of the radius, right? So we have this equation. If you see an equation like this, just know the fact that you need to use completing a square, right? So now the first thing is that let's just rewrite everything first. So it's going to be 3x squared plus 6x, right, plus 3y squared. Then this is going to be minus 12y minus 33 is equals to 0, right? So we're going to take the 33 to the other side. So it's going to be 3x squared, right, plus 6x plus 3y squared. And it's going to be minus 12 is equals to positive 33. So the first thing first is that you need to get rid of what? Of this 3, because of when wanting something of completing a square, you need to make sure the fact that the coefficient of x squared, right? So you need to make sure that the coefficient of x squared and the coefficient of y squared is equals to 1, right? So let's do that. So we're going to divide throughout by 3. So this is going to be the same as 3x squared divided by 3 plus 6x divided by 3 plus 3y squared divided by 3 minus 12y divided by 3 is equals to 33 divided by 3. So what are you going to get? You're going to get the following. So you're going to get this as being x squared. Then this is going to be what? This is going to be x squared. This is going to be plus 2x, right? Then it's going to be plus y squared. Then here's going to be what? It's going to be minus 4y. Then this is going to be equals to 11, right? So now what we're going to do is we're going to separately find the completing of the square of this one. Then we're going to find the completing of the square of this one. So now let's start with the one that I highlighted in green, the one with x, right? So you're going to say x squared plus 2x, right? So first, since the coefficient of x squared is 1, because we already divided, we're going to find what? We're going to first, we're going to first find the half of the coefficient of x. So it's going to be a half multiplied by 2, right? Then that's going to give us what? That's going to give us 1. Then you're going to square that. So you're going to say 1 squared, right? And you're going to leave it like that, right? Then with that said, let's rewrite this. So you're going to have x squared plus 2x, right? Plus what? Plus 1 squared plus y squared minus 4y. Then some digits that we're going to add is equals to 11. Plus you need to add this one on the other side. So it's going to be 1 squared, right? So now we're going to deal with y. So with y, it's going to be y squared minus 4y, right? So we need to have the coefficient of y, right? So it's going to be a half multiplied by negative 4. I don't know why did I put a bracket. So it's going to be negative 4, right? And when you have that, you're going to get negative 2. Then you're going to square it. So when you square it, it's going to be negative 2 all squared. do not simplify this, right? So we're going to say what here? Plus negative 2 squared. And here we're going to say plus negative 2 squared, right? So now remember the fact that we want it in this form, right? That's how we want it. So now to get that form, your x is going to be from here, then your variable or your a is going to be this one, right? So it's going to be what? It's going to be x plus 1, because that's positive, right? All squared, then plus, open bracket, for your b here is going to be what? It's going to be the following. It's going to be this y, right? Then it's going to be this negative 2, right? That is why I said do not simplify. So you're going to get the following. So it's going to be y, then it's going to be minus 2. It's going to be all squared. Then this one, we're going to punch it into the calculator. You're going to say 11 plus 1 squared, right? Plus what? Plus negative 2 squared. So you're going to get 16. So you're going to have 16. So remember the fact that we want the coordinate of the center. So now our center is going to be what? It's going to be negative 1. Remember opposite sign when you take out, and it's 2, 2, because it's opposite sign, right? Then our radius, remember the fact that this one is what? Is r squared. So our radius, right, is going to be equals to what? It's going to be r squared is equals to 16, meaning r squared is equals to square root of 16. So therefore, r is going to be equals to what? It's going to be equals to positive 4. So our radius is equals to 4. And that's how you would do this question. So now we're going to do example 3, right? It says given that the circle with the center 0, 0 and the radius 4, right? So first they gave us the actual circle without a and b. So we know the fact that the original circle is x squared plus y squared is equals to what? Is equals to r squared. So let's write this circle here. So it's going to be x squared plus y squared is equals to 4 squared. So that's the same as x squared plus y squared is equals to 60. So the question says if the circle shifts 2 units down, so it's moving 2 units down. Remember the fact that 2 units down is going to affect b, right? So down means what? Down means positive. So this is going to be equals to positive what? Positive 2, right? Remember the fact that its opposite is sign. Down means positive. Then it says it moves how many units? It moves 1 unit to the right. So it moves 1 unit to the right. The right is a, right? So right is what? The right is going to be this side, right? So it's going to be, what you call this? Right, remember, it means what? Negative. So meaning this is going to be negative 1, right? So now with that said, we're going to have that our equation, this is write down the equation with the shifted circle. So this is going to be what? This is going to be the same as x, right? Minus what? Minus a all squared plus x minus b all squared is equals to r squared. Let's substitute our b and a. So this is going to be x minus 1 all squared plus x plus 2 all squared is equals to what? Is equals to, the radius is still the same. So this is going to be 16, right? So this will be the new equation when it's shifted. Now we're going to do this question, right? It says a circle with a center, what you call this, a circle with a center on the line y is equals to negative x, right? Negative x plus 5 passes through the point 5 is to 8 and q, which is what? Which is 9 is to 4. Then they want us to determine the equation of the circle. Just to see it visually, let me just show you what's happening here, right? So you have a circle. So you have a circle. Okay, yeah. You have a circle here, right? And you have your center, right? Then there's a line, the straight line is passing through this center, right? Do you see that? So this line y is equals to negative x plus 5 is passing through the center. Then there's a point P, and I'm just going to do it randomly, and a point Q somewhere, right? A point Q, right? So this is how the graph looks or the situation looks, right? So now you need to determine the equation, right? So what's happening is that you have, if we take the entire equation, you have x minus a all squared, right? Plus, then it's going to be y minus b all squared is equals to r squared. How many unknowns do you have? 1, 2, 3, right? So we need to get rid of one of the unknowns, right? So we know the fact that this point here, do you see this point here? We know the fact that the point A is 2B, right? So what do we know? We know the fact that since the line passes through this point, right, is that I can rewrite the point A and B, right, in terms of this equation, right? So I know the following. I know the fact that this is going to be the same as B is equals to what? Is equals to negative A plus what? Plus 5. That's me substituting the center. The center what? The center. So what you got is the center A is to B. When I substitute the center A is to B into what? Into Y, I'm getting this. And what do I see? I can rewrite this center now. So the new center, right? The new center, we know the fact that it's A is to B, right? But I can rewrite it now in terms of A. So we know the fact that we can write it as A is to what? Is to negative A plus B, right? And do you see the fact that if now my center is only A, do you see what's going to happen? It's that now my equation is only going to have two unknowns, meaning it's going to have only A and R. So I can use simultaneous, which is nice because if I have 2 points, so I can create 2 equations, right? So now let's rewrite this equation with my new center, which is in terms of what? Which is going to be in terms of A. So let's do that. So it's going to be x minus A all squared plus, then this is going to be y, right? Minus, then this is going to be what? Minus A plus 5, right? And this is going to be all squared is equals to r squared, right? So this is going to be what? This is going to be x minus A all squared plus this one, let's simplify it, is y plus A, then it's going to be minus 5, then it's going to be squared is equals to what? Is going to be r squared. So now do you see the fact that our equation is only in terms of A, right? So now what I'm going to do is I'm going to substitute. Remember, we want simultaneous, right? So I'm going to substitute P, right, here to get my first equation. So when I substitute P, which is 5 is to 8, let's substitute that, right? So we're going to have the following when we substitute P. We're going to have that at X is going to be 5 minus A all squared, right? Plus, then it's going to be what? It's going to be 8 plus A minus 5 all squared is equals to r squared, right? So this is the same as what? This is the same as 5 minus A all squared plus, then we're going to have what? A, right? A plus 3, right? So it's going to be A plus 3 all squared is equals to what? It's going to be equals to r squared, right? Do you see the fact that the only two unknowns is A and R? So let's expand both of them. Here it's going to be 25, right? Minus 10A, right? Plus A squared. Then here's going to be what? Plus A squared, right? There's going to be plus 6A. Then this is going to be plus 9 is equals to r squared. Group like terms, this is going to be the same as 2A squared, right? Minus 4A, right, plus 34 is equals to r squared, right? So thus we're going to name it equation 1. So we're going to name this equation 1, right? So now we need equation 2, right? So to get equation 2, we're going to substitute what? We're going to substitute Q, right, which is what? Which is 9 is to 4. So let's do that, right? So we're going to have what? We're going to have 5 minus, not 5, it's going to be, so we're going to have the following. We're going to have 9, right, minus A all squared plus it's going to be 8, right? So it's not 8. Why do I keep on substituting the coordinate of V, right? Y here is going to be what? It's going to be 4. So it's going to be 4 plus A, right, minus 5. Then it's going to be what? All squared is equals to r squared. Let me just check that I didn't do a mistake. It's 9 here, which is correct, which is x and it's 4. I'm just looking corresponding with this one. Okay, makes sense, right? So now this is what? This is going to be the same as having 9 minus a all squared, right? It's going to be squared here. Yes. So this is going to be squared, right? And then this is going to be plus, then this is going to be the same as a minus 1 all squared is equals to r squared, right? So now expand this. This is going to be the same as 81, right? Minus 18a. Then this is going to be plus a squared, right? Then this is going to be minus what? Minus, then this is going to be plus. So it's going to be plus a squared, right? Minus 2a. Then it's going to be plus 1. And this is going to be equals to r squared, right? So now I'm just going to continue it here. So when we simplify that, we're going to have the fact that 2a squared, right? Minus what? Minus 20a, right? Plus what? Plus 82, right? Is equals to r squared. So what's nice is that this is going to be equation 2, right? So what's nice, do you see the fact that both equation 1 and equation 2, they both equals to r squared? So I can equate them together and basically solve for a. So that's what I'm going to do. So I'm going to say 1 is equals to 2 because of the r's, right? So you're going to have that 2a squared minus 4a, right? Plus 34 is equals to what? To 2a squared minus 20a plus 81, right? I'm going to take the one with the variable to one side, the one with just the numbers to the other side. So here's going to be what? It's going to be 2a squared minus what? Minus 2a squared minus 2a squared minus 4a. Then this is going to be plus 2a, right? This is not, it's going to be plus 20. This is going to be 20. Made a mistake. This is 20a. So this is going to be 20a, right? Plus 20a. Then this is going to be equals to what? To 80. And this is 82. Right, sorry. This is going to be 82 minus 32. Just checking. Yes, minus 32, right? So 34. Why am I saying wrong things? 34, right? So you're going to have the following. This ones are going to cancel out. Then you're going to have negative 4 plus 20, which is you're going to get what? You're going to get 16. A is equals to 82 minus 34 is going to give you what? It's going to give you 48, right? Divide both sides by 16, so it's going to be 48 divided by 16, which is you're going to get 3. So your A here is going to be equals to what? It's going to be equals to 3. So now you're going to substitute A into what? Into this 1 or 2. It really doesn't matter. So I'm going to substitute it at 1, right? So it's going to be r squared is equals to what? It's going to be equals to the following. So it's going to be 2. Then it's going to be 3 all squared minus 4. Then this is going to be 3. And this is going to be plus 34, right? Then when you paste that into the calculator, I'm going to get that my r is going to be what? My r squared, I'm going to get it as being 40, right? So now I have my r squared. So I have my a and I have my r squared. So I'm left with my b. So remember that b is this relationship, right? So now I'm going to substitute. Let me just do it here. Substitute a equals to 3 into what? Into b is equals to negative a plus 5. So it's going to be b is equals to what? Is equals to negative 3 plus 5, which is going to give us what? Which is going to be 2, right? So we have our b. So to write our equation now, it's going to be x, right? So it's going to be x. Remember, since a is positive, here is positive outside. So this is going to be minus 3, right? Then it's going to be minus 3 all squared. And then all squared, because remember the fact that this a and b is the center. Don't forget the fact that this a and b is basically the center. So it's the center point. So it's the same as having it like this, as being 3 is 2 2, right? So that's why we write the opposite side. So this is going to be plus, then this is going to be what? Y minus 2 all squared is equals to 40. And that's how you will find the equation for this question. Now let's just do a question from past paper, right? So it says what? It says in the diagram, PKT is a common tangent. So we see the fact that PKT is a common tangent, right? And it says on both the graph with what you call this at K, right? For both the circles. So this circle and the small circle and the big circle, right? Then they tell us the fact that the center of both the circle line and then on the line, which because they say the center, right? The centers of both the circles lies on the line y is equals to what? Y is equals to 1 over 2x. And the other one is what? And the center, then they tell us the factor. So we know the fact that I can rewrite the center in terms of what? In terms of this y. That's what it means. Like the previous question that we did before we did this question, right? So now they tell us the fact that the equation of the circle with the center, with the center O, which is this one, the big circle, is what? They give us the equation of that circle. So we know the fact that equation of the big circle is that, right? Then they tell us the radius of the circle, right, is 3 times, right? So they tell us that the radius of the circle, right, is 3 times, right, that of the circle centered at M. So we know what? We know the fact that this radius, right? So we know that the radius of the circle, of the big circle, so it's going to be R is equals to 3 times of what? Of the radius of M. That's what it means, right? That's the information that we have, right? So now with that said, we can start and answer the question. So I'm going to split this video into 3 parts. I'm going to answer 4.1 and 4.2, right? Then I'm going to answer 4.3, which is alone. Then I'm going to answer the last 2, right? So now let's do 4.1. So it's going to be 4.1. It says what? It says write down the length of OK, right? So where's OK? OK is this one. Do you see that? What is OK? Do you see the fact that OK is the radius? Do you see the fact that OK is the radius of this circle? Do you see the fact that this circle is the equation of this one, right? So if we know that OK is the radius, we know the fact that the circle equation is in this form, is x squared plus y squared is equals to r squared. So we know the fact that r squared is equals to 180 degrees. So therefore r is equals to the square root of what? Of 180 degrees. They said we must leave our answer in such form. So you're going to say the square root of 180, right? 180, so it's going to be r is equals to what? 26 root 5, right? So you sorted with that one. So the second one says what? It says that we need to show that k is a point. We need to show that k is a point. Negative 12 is 6, right? Negative 6. So 4.2, we're basically determining the point of k, right? So what do we see about the point of k, right? Is that it's the intersection, right, between where? Between this line, and this circle. Do you see that? Is the intersection between this line and the what? And the circle. Do you see that? So with knowing the fact that it's the intersection, meaning I can equate this, right, line and this circle together, right? But remember the fact that with intersection here, because we're dealing with circle, we're not going to equate them. So wherever I see what you call this y, so what I'm going to do, with knowing that there's an intersection, we know the fact that k is a intersection, right? Intersection of the line y is equals to 1 over 2x, right? And big circle. And big circle, which is, I'm going to write the equation, which is x squared, right, plus y squared is equals to 180, right? So you know the fact that normally with intersections, we equate them together, but here I'm not going to do that. So here what I'm going to do is I'm going to substitute y equals to 1 over 2, right, y, which is equals to 1 over 2x into what? Into the big circle, which is going to be x squared plus y squared is equals to 180. So now, wherever I see y, I'm going to substitute by this, right? So it's going to be x squared, right? Plus, open bracket is going to be 1 over 2x, right? Then this is going to be what? All squared plus 180. This is not decrease, right? So now what we're going to have here is going to be x squared plus x squared divided by 4 plus 1. It's equals to, what do I say plus? It's equals to 180, right? So it's going to be what? It's going to be x squared, right? So you're going to say 1 plus 1 over 4, right? Which is going to give you 5 over 4. So let me just do that. So it's going to be this one. Let me just erase here. So this is going to be equals to. So this is going to be equals to 5 x squared divided by 4 is equals to 180, right? So this is the same as divided by 1. So I'm going to cross multiply. So it's going to be 5x squared because it's going to be 5x squared multiplied by 1, which is going to be 5x squared. Then it's going to be 180, right? What you call this multiplied by what? Multiplied by 4. So now you're going to have the following. You're going to have 5x squared is equals to 180 multiplied by 4, which is going to be 700 and what? 720, right? Divide both sides by 5. So it's going to be 720, right? So it's going to be 720 divided by what? Divided by 5. So you're going to get 100 and what? You're going to get the fact that x squared is equals to what? It's going to be 144, right? Then you're going to square both sides. So when you square both sides, you're going to have the fact that it's going to be x is equals to plus or minus 12, right? So this is going to be plus or minus 12. What do we see? We see the fact that plus or minus 12, meaning a here needs to be x here first, needs to be equals to negative 12, because do you see the fact that it lies in the negative x-axis, right? So therefore, we know the fact that a is equals to what? Is equals to negative 12, right? So now with that one, I'm going to substitute, right, my x equals to negative 12 into what? Into my y equation. So it's going to be y is equals to what? To 1 over 2, right? Then it's going to be negative 12. Punch that into the calculator, you're going to get negative 6, right? So we know the fact that now b is equals to negative 6. So meaning the point of k is going to be negative 12 is to negative 6. And that's how you would solve this question. Now we're going to do the second half, right? It says determine the equation of the common tangent PKT. So I'm going to highlight that common tangent, which is this one, right? So with that one, what do we know about the relationship between this tangent line and the line coming from center, right? We know this from Euclidean is that tangent and radius is what? It's 90 degrees, right? So this is 90 degrees, right? So they are perpendicular to each other. And what do we know about the relationship of perpendicular lines, right? Is that the gradient, and I'm going to say the gradient of the tangent multiplied by the gradient of the radius needs to be equals to negative 1. We already have the gradient of the what? The gradient of the, of the radius, right? Remember the fact that this line here passes through the center, which gives us the gradient. So this 1 over 2 is actually the gradient of the what? It's actually the gradient of the radius, right? So we already know that the gradient of the radius is equals to a half. So now we're going to solve for the gradient of the tangent. So it's going to be what? It's going to be mt multiplied by a half is equals to negative 1, right? So now take the negative a half to the other side. So it's going to be mt is equals to negative 1, right? Divided. So it's going to be negative 1 divided by a half. So therefore, you're going to have your answer as being what? As being that mt is equals to what? Is equals to negative 2. And the reason why we're doing this is 4.3.1, right? The reason why we're doing this is that the equation of the tangents is mx plus c, right? We need the gradient, which is we just found, and we need c, right? So with c, we need just a set of coordinate, and which is nice because we already calculated what's k, right? So now we know the fact that y is going to be equals to what? 2mx plus c. Let's substitute the gradient of the tangent. It's going to be y is equals to negative 2x plus c. So we want to solve for c, right? So we're going to substitute what? We're going to substitute k into y to solve for c, right? So it's going to be what? It's going to be negative 6 is equals to negative 2, open bracket, negative 12, right? Plus c, which is going to be the same as negative 6 is equals to negative 2 multiplied by negative 12 is going to give us what? It's going to give us negative 24. So this is going to be 24, not negative, positive 24, because they're going to be positive, and this is going to be plus c. So when you say negative 6 minus 24, it's going to give us what? Negative 30. So this is going to be negative 30 is equals to c. So therefore, y is equals to negative 2x minus 30. So that's going to be the equation of the tangent, right? So now, let me just erase this part, right? So now, we're going to move on to what? To the coordinate of m, right? So what you call this one, which is going to be this one, 4.3.2, right? We need the coordinate of m. Do you see the fact that m is the what is the coordinate of the center, right? So what do we know? We know the relationship that x minus a all squared plus y minus b all squared is equals to what? It's equals to r squared, right? What information did they tell us from this side? To remember the fact that the radius of the big circle, we know the fact that the radius here, it's given that the radius, this statement, is that the radius of the big circle, right, is equals to what? Is equals to 3 times, right, of the radius of the small circle. So the radius of the small circle. So with that said, we already know what's the radius of the big circle, right? We already calculated it, which was okay, right? So now we can calculate the radius of the small circle. So knowing that, we know the fact that the radius of the big circle is equals to 3 times the radius of the small circle. The radius of the big circle we calculated as being what? As being the square root, right? As being 6 root 5, right? And this was equals to 3r. So I'm just going to call it r because I'm looking for this distance, right? Because that's the radius of the small circle. So now with that said, I'm going to have the following. I'm going to have 6 root 5, right? So it's going to be 6 root 5. And that's going to be divided by what? Divided by 3. So I'm going to have 2 root 5 is equals to r, right? So that's that. So I'm going to substitute it back here. So we know the fact that it's going to be x minus a all squared, right? Then this is going to be plus, then this is going to be what? This is going to be y minus b. Then this is going to be all squared is equals to what? 2 root 5. Then this is going to be squared. Simplify that. It's going to be x minus a all squared, right? Plus, then this is going to be what? Y minus b. Then this is going to be all squared. Then if you say 2 root 5, right, all squared, we're going to get the following. We're going to get 20. So this is going to be 20, right? So now we know that, right? So what do we know again? We know the fact that we can write this center. So we can name this center, not A and B, because A and B is already taken. Let's name it XM, yes, and YM, right? So I know the fact that I can write this equation in terms of this line, right? Because it passes through. So I know the fact that if I substitute XM here, I'm going to have the fact that YM is equals to what? Is equals to 1 over 2 XM. So I can write this point here. So I can write M, right, as what? As XM, right? Instead of writing Y, I'm going to substitute by this. So this is going to be what? 1 over 2 XM. Right? So because of this relationship, right? So now I can rewrite my A and B. Remember, A and B is what? It's now this, right? In terms of what? In terms of xm and 1 over 2 xm. So let's do that. So it's going to be x minus, then A is what? It's going to be xm, right? Then this is going to be all squared. Then this is going to be what? Y minus. Then this is going to be my B. Remember what? It's 1 over 2 xm, right? And this is going to be equals to 20, right? So do you see the fact that now, if I substitute this point K, because of this point K, right, is like a common line going through here, right? I can find what? I can find this point K touches the small graph. That's why I can substitute it, right? Is that I can find my xm, right? Then after finding my xm, then I can find my ym, which is the coordinate of m, right? So let's simplify this first. So this is going to be x minus xm, right, all squared. Then this is going to be plus, this is going to be y. Then this is going to be minus 1 over 2 xm, right? And this is going to be equals to 20. So now we're going to substitute k, right? Which is negative 12 and 6. So let's do that. So you're going to get the following. You're going to have negative 6 minus xm all squared, right? Plus, then here we're going to have what? We're going to have not negative 6. We're going to have, it's going to be negative 12. So it's going to be negative 12 minus xm all squared, right? Then this is going to be plus. Then here we're going to have what? Negative 6 minus 1 over 2, right? xm. Remember the fact that this one is squared. I forgot this squared. Yes. Then this is going to be what? All squared is equals to 20. Do you see the fact that now everything is in terms of what? Everything is now in terms of what you call this xm, right? So now what I'm going to do is I'm going to expand it, right? So we're going to expand it. So when we expand it, we're going to have the following. We're going to have the fact that this is going to be the same as negative 12 minus xm all squared, right? Another bracket, negative 12 minus xm. So let me just take it up a notch here. I need space. So I'm going to just take it here. It's going to be negative 12, right, minus xm. Then it's another bracket. It's going to be negative 12 minus xm, right? And this is going to be plus. This is going to be negative 6 minus 1 over 2 xm, right? So this is going to be xm. Then this is going to be another bracket, negative 6 minus 1 over 2. And this is going to be xm. Then this is going to be equals to 20, right? So now let's expand this. It's going to be negative 12 multiplied by negative 12. So if you say negative 12 multiplied by negative 12, we're going to get negative, positive 144, right? Then when you say negative 12 multiplied by what? Multiplied by negative x squared is the same as mine. Is going to be the same as positive 12xm. Then if you say negative 12, would you say a negative xm multiplied by negative 12? You're going to get another positive xm, right? So you're going to have, now you're going to have negative xm multiplied by negative xm. So it's going to be positive xm squared, right? Then we're going to deal with this one. So it's going to be plus negative, it's going to be negative 6 multiplied by negative 6. It's going to give you 36. So it's going to be 36 here, right? Then you're going to have what? You're going to have negative 6 multiplied by negative a half, right? So we're just going to give you plus 3xm, right? Then again, it's going to be plus 3xm, right? Then you're going to have a half multiplied by a half, right? Which is going to give you what? Which is going to give you plus x squared divided by 4, right? Then this is going to be equals to 20, right? So now we're going to group like terms, right? So this is going to be what? 20. before I do a mistake. This is 20, right? Then we're going to group like terms. So constant, I'm going to highlight all of them. So it's this one, then it's this one, it's this one, that's it, right? So it's going to be that 2, so it's going to be what? It's going to be 144, right? Plus 36, which is going to give me 180, so it's going to be 180, right? Then we are done with that one, right? So now let's highlight the next 2 terms. The next common terms is going to be this one is the same as this one, is the same as this one, is the same as this one, right? So it's going to be 12 plus 12 plus 3 plus 3, which is going to give us 30. So this is going to be plus 30 plus 30. So this is going to be plus 30 x m, right? Then you're going to have what? You're going to have, so this one we done, so this one's we done, right? Then we're going to have the following. We're going to have this one plus this one, right? So with that one, we're going to have the following. So if we say 1 plus what? 1 plus, 1 plus 1 over 4. We're going to get the following. We're going to get our answer as being what? As being plus 5 over 4. Then this is going to be x m squared, right? And this is going to be equals to 20, right? So just go to the next page. We have 180 here, right? 180 plus 30 xm, right? Then we have plus 5 over 4 xm squared. Then that's equals to 20. So that's equals to 20, right? So we're going to basically take the 20 to the other side. So we're going to have what? We're going to have 180 minus 20 plus 30 xm plus 5 over 4. And this is going to be xm squared is equals to 0, because we need to factorize this, right? So when you say 180 minus 20, we're going to get our answer is 160. So it's going to be 160 plus 30 xm, right, plus 5 over 4, right, x squared is equals to 0. So I'm going to rewrite it, making xm squared the, what you call this, in front. So this is going to be 5 over 4 xm squared, right, and this is going to be plus what? Plus 30 xm, right, and this is going to be plus what? Plus 160 is equals to 0, right? Then what we're going to do now, I'm going to basically get rid of this 4. So I'm going to multiply throughout. So this is going to be 5 xm squared, right? Plus when you say 30 multiplied by 4. So when you say 30 multiplied by 4, you're going to get 120. So this is going to be 120 xm. Then when you say 160 divided by what? Divided by 4, what you call this, when you say 160 multiplied by 4, you're going to get your answer as being plus 600 and what? 640 is equals to 0. So I can divide throughout by 5. So this is the same as xm squared. When you say 120 divided by 5, you're going to get 24. So this is going to be 24, right, xm. And this is going to be 640 divided by what? Divided by 5, which is going to give me 100 plus 128, right, is equals to 0. So now we're going to factorize this. So when you factorize it, you're going to have that this is xm, right, plus 16. Then it's going to be what? It's going to be xm, right? Then this is going to be plus 8. And that's going to be equals to 0, right? So now, meaning xm is equals to negative 16, or xm is equals to what? It's equals to negative 8, right? but it cannot be negative 8, right? So our answer is that xm is equals to negative 6. So now with that said, we can substitute this xm. Remember the fact that that relationship, the new relationship that we formed, right? This relationship. I'm going to substitute my xm there. So now I'm going to substitute, remember, let me just write it here. I said that ym is equals to 1 over 2 xm, right? So I'm going to substitute, x equals to negative xm equals to negative 16 into what? Into ym, right? Which is going to be equals to 1 over 2 xm, right? So with that said, I'm going to have the following. I'm going to have the fact that ym is equals to y to 1 over 2. Then it's going to be negative 16. So that's going to give us what? That's going to give us negative 8. So ym is equals to negative 8, right? So now, meaning my point m here, so meaning that m is going to be equals to what? Is going to be equals to negative 16 is to negative 8. So that's how you would find the coordinate of m. So now I'm going to answer the third question for this part, right? Which is going to be the last question for this part, which is 4.3.3, right? It says write down the equation of the smaller circle. So we know the fact that this is going to be y minus what? Minus a, right? All squared plus what? Plus y minus b all squared is equals to r squared, right? So here, remember, we found our m as what? Let's go back. We found it as negative 16 and what? Negative 8, right? So we found it at negative 16 and negative 8. So, and again, remember the fact that we know this radius, we've calculated it. Also, we know that r, remember that r is equals to 2 root 5. So I know that r of the small circle is equals to 2 root 5, right? So I know the fact that r is equals to 2 root 5 and a and b, I have it. So this is going to be the same as, since it's negative 16, it's going to be positive. So it's going to be plus 16 squared. Then this is going to be plus y. Then it's going to be plus 8 squared is equals to 2 root 5, right? All squared. So this is going to be the same as x plus 16 all squared plus y plus 8 all squared is equals to, it's equals to, open bracket, 2 root 5 all squared, right? Which is going to give us 20. So this is the equation of this, of this smaller circle. So now let's do 4.4, right? It says, for which values of r will another circle with the equation x squared plus y squared is equals to r squared intersect the center of m, right? At point m will have two distinct roots, right? When is that going to happen, right? So 4.4, it's going to happen when r is between what? It's greater than the big radius. So it's greater than the big radius, which is okay, right? And it's less than what? Is less than the big radius plus 2 times the what? 2 times the small radius, right? So that's when this is going to happen. So we know that the big radius is equals to what? It's going to be equals to the square root of 180, right? Then this is going to be what? This is going to be r. This is going to be 180, right? So this is going to be root 180. Remember the fact that we already know what's the small radius. Let's go up and go find it. We know the fact that it's 2 root 5. So this is going to be multiplied by 2 root 5, right? So let's simplify this part. So it's going to be root 180 gives us what? Gives us 6 root 5, right? Then r here is going to be what? It's going to be root 180, right? Plus 2, open bracket, 2 root 5, right? So you're going to get your value as being what? As being 10 root 5, right? And that's how you would do this question, right? Now we're going to do 4.5, right? It says another circle, which is x squared plus y squared plus 32x plus 16y plus 240 is equals to 0 is drawn, right, then they tell us the fact that proof by calculation that the circles, right, proof by calculation that the circle does not cut the circle. So it does not cut, meaning it does not have any intersect, right? Does not cut the circle with center M, right? So now to understand that, we need to understand this following properties, right? Is that if I find for the new circle, right? If I find the fact that the center of M and the center of the new circle are the same, do you see the fact that through the diagram, there is no intersection, there is nothing, right? So meaning there is not going to be any intersection. The new circle is not going to cut through, right? Not going to cut through at all. And that's what we need to prove, right? Then if, let's say, we find instant the fact that, what you call this, the distance between r squared minus r1, right? It's like this, right? Then my thing means what? It means the fact that it just touches the what? It just touches the graph, right? Then if the intersecting is that the distance, right? And this is the distance. When we say distance, we mean this line, right? The distance, right? Or from one, from one center to another. So this is D, just to see, this represents D, and then the distance from one point to another is going to be what? It's going to be less than what? Less than the what? Less than the sum of the two radius. So the radius of this one, and so this is going to be R2 and R1, right? So that's what it means, right? Then if the distance are exactly equal, that means the fact that they are touching. If I take the distance, which is this entire line, right? And I find the fact that it's equals to the radius of this circle and this circle, right? That means the fact that they're touching each other, right? And if the distance here, which is D, is greater, right? Meaning it's greater than R1 and R2, right? That means the fact that what? They are far apart, there is no intersection, right? So when is it going to touch? It's going to touch when the distance, when you subtract them, right? When you subtract the distance, meaning the circle is inside, right? So if I take this distance, which is D, right? And that is equals to me taking R1 and R2, right? And I see the fact that they equal, that means the circle is inside, right? And as I explained the following. So now what we're looking for, we're trying to prove the fact that this situation, we're trying to prove the first situation, because they said proof by calculation. So we're basically trying to prove the first situation, and that's what we're trying to do. We're trying to prove the fact that the circle of the center of the new circle and the center of this one, right, M, is the same thing. So I need to get my center here as being negative 16 and 1. So let's do that, right? So it's going to be the following. So let me just take my blue pen. It's going to be x squared, right? And it's going to be plus y squared. Then it's going to be plus 32, right? Plus 16 y. Then this is going to be plus what? Plus 240, right? So it's going to be 240 is equals to 0, right? So I'm going to take the 240 to the other side. So it's going to be x squared, right? Then I'm going to group the x squared and y squared. So this is 32x, right? So it's going to be plus 32x, right? And this is going to be what? This is going to be plus y squared. And it's going to be plus 16y is equals to 200 and negative 240, right? So now what I'm not going to do, I'm going to basically do completing the squared here, right? So I'm going to deal with just x, right? Let's just do that. It's going to be what? We see the fact that it's x squared and here's y squared, so I don't need to divide anything throughout. So here we're going to have 32. So I'm going to half it, sorry, half 32, right? So it's going to be a half of 32, right? Which is going to give me 16. Then I'm going to square it. So I'm going to square it. It's going to be 16 all squared, right? Let's do this one now. It's going to be a half of what? A half of. So it's going to be a half of 16, which is going to be equals to 8. right? Then we're gonna square it, right? So it's gonna be the following. It's gonna be equals to half of 16, so it's gonna be 8 all squared, right? So now we're gonna substitute, so it's gonna be the same as x squared, right? Plus 32x, then you're gonna say plus 16 squared, right? Plus y squared, right? Plus what? Plus 16y. Then you're going to say plus, here's going to be 8 squared. And this is going to be equals to what? This is going to be equals to negative 40, negative 240, right? Then we're going to add plus 16 squared plus 8 squared, right? So let's simplify this. Remember the fact that you're going to take what? You're going to take this one and this one, right? And for y, you're going to take this one and this one, right? So it's going to be the same as x plus 16, right, all squared. Then this is going to be what? This is going to be plus y plus 8, right, squared is equals to, when you say negative 240 plus 16 squared, right, plus 8 squared, you're going to get your answers being 80. So you know the fact that this is going to be 80, right? So this is going to be your circle of this one, right? This is going to be your new circle, right? So what do we see? We see the fact that the center of the new circle is what? Is negative 16 and negative 8. Do you see the fact that it's exactly as M, right? So that proves what? That proves the fact that what? That proves the fact that they share the same center. So therefore, right, the circle, so the circle, therefore the circle, right? So therefore the circle, let's say the new circle, the circle will never touch, will never cut, right? Will never cut the circle M, as they have the same center, as they have the same center, right? We know the fact that they have the same center, and also their radius is unequal, right? So we see the fact that here the radius of root, so if we find r here, r is equals to what? To 80, right? So it's going to be 4 is to 5, and the radius of this one, remember, was 2 is to 5. So we know the fact that they don't have the same they have the same center, but their radius are unequal. So, but their radius are unequal. So that's how you would solve this question.